Hello everyone and welcome to the lecture on Aurora Serverless. So this lecture will contain all those topics. What is Aurora Serverless? How Aurora Serverless V2 works? Understanding Aurora capacity units. Aurora Serverless V2 scaling. Performance and scaling for Aurora Serverless V2. So what is Aurora Serverless? Aurora Serverless V2 represent Amazon Aurora's advanced configuration that provides on-demand auto-scaling capabilities for database management. This version brings automation to the core of database operations. The system continuously monitors your database workload and automatically adjusts capacity based on real-time application demands. This removes the burden of manual capacity management and ensures optimal performance. The service implements a pay-per-use billing model where charges are based solely on the resources your database clusters actually consume. This eliminates waste from unused computing resources and helps organizations maintain budget control. This automation proves particularly valuable in specific scenarios such as multi-tenant databases, distributed database systems, development and test environments, and any situation where workloads are highly variable and unpredictable. How Aurora Serverless V2 works? Aurora Serverless V2 excels with workloads that vary significantly, from retail and gaming sites with promotional events to on-demand reporting databases and development environments. It is particularly valuable when workload patterns are unpredictable and capacity planning is challenging. While provisioned clusters suit steady workloads with predefined capacity needs and planned adjustments, Serverless handles dynamic requirements without capacity constraints. Provisioned clusters require manual modifications and may experience brief outages during changes. Built from the ground up for instant scalability, the system maintains provisioned level security and isolation. The dynamic scaling mechanism minimizes overhead while responding rapidly to workload changes and processing demands. Users specify minimum and maximum capacity ranges rather than fixed allocations. Each writer and reader in the cluster scales independently within these bounds, leveraging multi-easy deployment for both dynamic scaling and high availability. The system optimizes performance by maintaining writers and readers on the same host during scaling. When host migration is necessary, connections are managed automatically without requiring changes to the application code or connection strings. Storage and compute capacities are managed independently, which allows clusters to maintain large data volume, terabytes scale, even with minimal compute resources. This separation enables efficient resource utilization and cost management. So, understanding Aurora capacity units, also known as ACUs. Each Aurora capacity unit combines approximately 2 GB bytes, which is, you can just think of a 1000 MB. So 2 GB bytes of memory with corresponding CPU and networking resources. Unlike provisioned clusters, Aurora Serverless V2 uses ACUs, Aurora capacity units, as its standard capacity measurement unit. The system tracks capacity as a floating point number representing ACUs for each writer or reader. This measurement occurs every second and adjusts as the components scale up or down. Administrators define a capacity range by setting minimum and maximum capacity values. This range applies uniformly across all Aurora Serverless writers and readers within a DB cluster. The system provides two key metrics: serverless database capacity and ACU utilization, to help administrators monitor actual database capacity usage and its position within the specified range. While each writer and reader maintain its own capacity value, they all operate within the same defined capacity range for the cluster. This allows for independent scaling while maintaining consistent boundaries. Aurora Serverless V2 scaling. Aurora continuously tracks resource utilization, which is CPU, memory, and network, for each Aurora serverless reader and writer, scaling up when capacity is constrained or performance issues are detected. Writers process all DDL, which is data definition language statements and data modifications, while readers handle read-only operations like select queries. Each writer and reader has an independent capacity value measured in ACUs, scaling up when current capacity is insufficient and down when excess capacity exists. Unlike Aurora serverless V1's doubling approach, this is previous version, so it's no longer much in use. So that's why this lecture is specifically for V2, which is the current, and most clients will use this. So unlike serverless V1's doubling approach, V2 scales incrementally. Minimum, it starts with 0.5 ACUs with larger increments at higher capacities for faster scaling. Monitoring is done through CloudWatch metrics like serverless database capacity and ACU utilization rather than discrete scaling events. Reader scaling can be configured either to match writer scaling, promotion TS from 0 to 1 for high availability, or scale independently. This is in TS between 2 to 15. V2 scaling occurs without disruption, eliminating V1 scaling points and timeout periods. Scaling can happen during active connections, transactions, and table operations. Multiple Aurora serverless V2 readers can be added to handle increased read capacity requirements, each scaling within the cluster's defined maximum capacity range. Scaling behavior depends on the cluster's ACU settings, reader promotion tier configuration, and whether readers are set to scale with the writer or independently. So something about performance and scaling. So this is more about performance. We have seen the scaling part already. Aurora serverless capacity management involves setting minimum and maximum ACU ranges with various factors affecting the optimal settings, including scaling speed requirements, buffer cache efficiency, and workload patterns. The minimum ACU setting should be carefully chosen based on features in use, with recommended minimum of 2 ACUs for performance insights and 8 ACUs for Aurora global databases in the primary region. Maximum ACU settings should account for peak workload requirements, budgetary constraints, and the need to handle unexpected spikes, with values typically aligned with equivalent provisioned instance memory sizes. CloudWatch metrics like serverless database capacity, ACU utilization, CPU utilization, and freeable memory are crucial for monitoring scaling behavior and capacity utilization measured every second. Parameters like InnoDB buffer pool size, which is applicable for Aurora MySQL, and shared buffers, which is applicable for Aurora PostgreSQL, are automatically adjusted during scaling, while max connections is set based on maximum ACU capacity and requires a reboot to update. The max connection parameters has predefined limits based on the maximum ACUs, which can range from 90 all the way up to 6000 for MySQL, and from 189 all the way up to 5000 for PostgreSQL, with PostgreSQL capped at 2000 when minimum capacity is 0 or 0.5 ACUs. Performance monitoring tools like Performance Insights provide specialized counters for Aurora serverless, including serverless database capacity, ACU utilization, max configured ACU, and min configured ACU. So these are some important metrics when it comes to performance insights. Common scaling issues can arise from enabled features like global databases or performance insights, background processes, large database volumes, or memory fragmentation, potentially preventing scale down to minimum capacity. Parameter groups work similarly to provision instances, but Aurora overrides certain capacity-related parameters for optimal scaling performance, particularly those affecting memory and processing capabilities. Out-of-memory errors can trigger an incompatible parameter status requiring actions like increasing capacity limits, reducing workload, or turning off memory intensive features to resolve. And that's all. Thanks for watching.